Hello everyone, welcome to my YouTube channel. So in this video, I'm going to show you how we can perform instance segmentation using YOLOv8. I have created another video called how to do object detection using YOLOv8. If you haven't watched that video, so you can watch, I will give that link in the description. So if you want to do like object detection on your custom data, it is also possible. So I already created one video, so you can refer that video. But in this video, I will show you like how you can perform image segmentation, okay, which is nothing but instant image segmentation, okay, using YOLOv8. In my previous video, I already discussed about this YOLOv8 in detail, okay, what are the things actually it has, how this API works, okay, everything I have discussed. So just try to watch that video so it would be very much clear, okay. So in this video, I'm not going to explain all the thing. I will show you the core part, okay, in this video only. So if you see here, using YOLOv8, actually you can perform three kinds of tasks like detection, segmentation, okay, then classification. So we have already covered the detection part. So in this video, I will cover the segmentation part, okay, which is nothing but instance segmentation. And in future, I will create another video like how you can do image classification, okay, using YOLOv8. So instead of talking too much, let's start with our segmentation. So guys, here if you see, I created one folder inside my drive. Okay, so you just also need to create one folder inside your drive. I've just named it YOLOv8 seg, okay, that means segmentation. Here actually what I did, I kept my this notebook, okay, I prepared this notebook for the segmentation and I kept my data, okay. So now the question is like how I will get the data and how my data will look like, okay. I think I already discussed if you want to perform object detection, okay, using YOLOv8, what should be the data format and how we can annotate the data and all, okay. So in this video, I will also show you like how your data will look like. But see, segmentation annotation, like it's a little bit harder, okay, than your object detection, because here you do like you can say, so here actually you usually do polygon annotation, okay, but in our object detection annotation, we used to perform like you can say bounding box annotation. So we just used to create one boxes and we used to like save that file. But here it's not like that. You need to do like polygon annotation. I think you already worked with like you can say this one, your Photoshop, okay. In Photoshop, I think you used lasso, okay, lasso tool. There is a lasso tool is there. So if you want to select one image, so what you used to do, you used to select that image, okay, like you used to create a lots of dots and you used to select that image, okay. That's how actually you can perform polygon annotation, okay. So there are various tools you will find in the internet, like there is a one tool called label me, okay. Using label me, actually you can also perform these kinds of polygon annotation. So let me show you one tool like called label me. So if you just search label me, okay, label me in Google, label me GitHub, just search label me GitHub. Yeah, so using this tool also you can do polygon annotation, okay. So it is only for like annotating your data for segmentation task, okay. See here if you see, yeah, so this UI will look like that. So you just need to install this tool, okay, and you can annotate. But there one issue you'll be having. So the format actually it will save, okay, of your annotation file, it would be XML file, okay, but here we need .txt file, okay, which is nothing but YOLO format. So again, you just need to use some script to convert that XML to YOLO, but again, it would be like very much hard, okay, for you. So what I can suggest actually, there is another website I think you know called RoboFlow, okay. So just go to RoboFlow, because see, RoboFlow has already lots of data, okay. Although like it will provide some of the open source data, and if you need like some additional data, or if you need a lots of images, okay, at that time you just need to take their subscription, okay. But if you are exploring, okay, if you need some data to explore, so I think this free version would be work for you, okay. So here just click on universe, okay. So if you just click on universe, so here you will see there would be a search bar, okay. So here actually you can search, okay, like which dataset you need. So what I will do, I will search here instance segmentation, and if I search, so you will see lots of data, okay. So here if you see, there would be lots of data, and here you will find the data format, okay. It is like it is for object detection, it is for classification, so you need to look for segmentation, okay. So let's search specific data. I think Coral segmentation 4 if I search, okay. So here you will see some kinds of segmentation. See, cell segmentation mask, okay, it is instant segmentation data. So what I did, I already downloaded this data set, okay. So you just click here. If you just click on this data set, and here you will get download button. Okay, just try to download, but before that you need to create one account in YOLOv8. Okay, and you can use the dataset. So let me show you like how your dataset will look like. Okay, so guys, I have downloaded the dataset, okay, here, and it will look like that. So it will contain, these are the folders, some additional folder it will also contain, like this YOLOv8 readme and all. Okay, I have deleted those files because it is not required. Okay, so again, it would be the same for of like format, okay, as we did in our object detection one. Okay, so basically you will have three folders called train, test, and validation. Okay, so inside training you will have two folder called images and labels. Okay, so here if you see, I have all my training images. Okay, so these are all my training images, and this is cell data set. Okay, so these are some cells. Okay, so this cell actually we need to segment out. Okay, so guys, in this folder you will see like only 7 images are there. Okay, but actually just for the demonstration purpose actually we can use, but if you are training your actual model at that time, make sure you have a lots of images. Okay, so inside labels actually it will contain all the labels. Okay, so these are some txt file, so this is your annotation file. Okay, so these are some your polygon points. Okay, and this is the label, like, okay, it has been annotated as 0. Okay, so guys, I think you got it, like what should be the data format and all. And if you just download from this one, your RoboFlow, you don't have to annotate your data, it is already annotated. Even using RoboFlow, actually you can also annotate your data. Just upload your image and try to annotate your data, it is also possible. Okay, but you just use open source dataset just for exploration. So similar wise, in test, it will contain the same thing. Okay, and in validation it will contain the same thing. So one additional file you need to create called data.yaml. So let me open this data.yaml and show you what are the things you need to mention. So guys, this is my data.yaml file, and here you just need to mention your training image path, validation image path, and your test image path. Okay, and the number of classes you have, which is 1 for me, and the name of the classes, which is cell. Okay, because here I just only want to segment out the cell. Okay, from that image. Okay, so here if I show you the image again, yeah, so these are the cell. Okay, I just need to identify, and rest of the thing are background. Okay, if we talk about. So yes guys, this is the data set I have downloaded from this RoboFlow, and I will be using in this video. Okay, so what I did, I like created this folder called cell data, and inside that I kept all this file. Okay, now what I did, I uploaded this thing in my let me show you in my Google Drive. Okay, so here if you see cell data, I have uploaded here. So for your case, you just also upload. Okay, and one additional thing you need to do, this data.yaml file, just try to upload outside of this data folder. Okay, so let me do it. Yeah, so guys, I have uploaded this data.yaml. Now let's open this YOLO instance segmentation notebook. Okay, I will give everything in your resources section in the description. Okay, you can get from here data, this notebook, I will share everything. Okay, so guys, this is the notebook. So make sure you have selected your runtime as GPU. Okay, so for me it is already selected. Now let's connect the notebook. Okay, it's connected. Now let's run this first cell. So it will check your GPU, like which GPU instance actually you got in your Colab. Okay, so here actually I'm using a free Colab, so that's why I got Tesla T4. Okay, and let's check the directory we are in. So we are in content, which is nothing but this directory. Okay, so the first thing actually you need to do, you need to install this YOLOv8. Okay, which is nothing but you just need to install this Ultralytics. Okay, so this is the cell you just need to execute. So let me execute. And this thing actually I already covered in my previous video, like how to set up and all. Okay, everything I covered, you just refer that video. Okay, so it has already installed. And here if you don't want to install using pip, okay, so there is another way. You can clone this repository, and you can also install this one. It is also possible, but we won't be doing like that because I feel like this pip install is like more convenience, okay, than this one. So I already commented out for you, for just for your reference. You can also install like that way. Okay, so now let's import and see whether it's working or not. Okay, everything is working perfectly. Okay, now first of all, let's do some inference, okay, on this Pretrained model, okay, using CLI. Okay, and what is CLI, what is a Python SDK, I already discussed in my previous video. I'm again telling you. Okay, just try to refer that video. Okay, now First of all, what I'm doing, I'm just running one command called YOLO, and task is equal to I'm giving segment, okay, mode is equal to I'm giving predict, because I just only want to do the inference, okay, on my test data. And model, this is the model I'm using, okay. So now how I'm getting the model name, so just go to YOLOv8 repository, and here if you see this segmentation section, here you will have all the model name, okay. Just try to select any model, okay. So here if you see, I have selected YOLOv8s underscore this segmentation model.pt, okay. This is the confidence score you can set. I've just given 0.25, that means 25%. You can also increase and decrease, okay, based on your you can say requirement. Now this is one image actually I'm getting from this URL, so let me show you. This is one dog and person image, okay. So RoboFlow, they have published this image, so I will apply this image segmentation okay, inference on this image, okay, and let's see whether it is able to segment out or not, okay. Now here one parameter you just need to mention, save is equal to true. If you're not mentioning save is equal to true, it won't be saving that inference, okay, in this you can say dicks, okay. So that's why actually you just need to mention that thing. Now let's execute and see whether it is able to segment out or not. And not only this model, actually you can try with other model also. So I will keep this thing on you, okay. Just try to select this medium model, large model, X model, okay, and try to do the inference and see like the performance, okay, of your model. Now if I refresh here, so guys, now if you see, it has downloaded this doc.jpg, okay, and it has also downloaded this model YOLOv8s.segmentation model, this model, okay. Then it has created one folder called runs. It is telling like all the result had been saved to this folder, okay. And then segment, predict, okay, inside that it has predicted and saved this file, okay. Now if you want to visualize this file, so you just need to provide the path, okay, of this image. So it is inside runs, segment, predict, and doc.jpg, okay. Just copy the path and paste it here, okay. Now let's execute and see whether it is able to detect or not. See guys, it has able to successfully segment out this image, okay. See, it is segmenting this person as person, this is dog, and this is segmenting as handbag. And if you see, it's pretty good, okay. There is a small car, it is also able to segment out, okay. It is amazing, like, okay. So yes guys, we have done some inferencing. Now it was using CLI, now let's do using SDK also. So SDK, you just need to pass your model path first of all. So just import YOLO, and inside YOLO just mention your model path, which is nothing but this path, okay, I'm mentioning. And after that, what I'm doing, I'm just calling model.predict. Then here I'm providing my source image, okay, and here I'm passing my confidence score. That's it. Now let's execute, and it will save all the results inside this result variable, okay. Now if you want to see like the boxes, so these are some your boxes, okay. These are the boxes, coordinate points it will return. And if you want to also see the confidence score, so these are the confidence score, okay, 64, then 65, 38, okay, all the thing it is printing. And if you also want to see the classes name, okay, see, these are some classes name. So it has predicted, I think 1 2 3 4 5 classes. Here also it is returning five classes, okay. 1 2 3 4 5, okay. Now if you want to also see the mask, so this is the mask coordinate, okay. Now I already told you, if you need your data, so if you need your custom data, you can refer RoboFlow, okay, to download your data set. And it has like lots of data set, okay. Here if you see the count, so here actually we have already downloaded the dataset, and we have already uploaded this dataset in my Google Drive. So first of all, I just need to mount my Google Drive, okay, with my this Google Colab, so that actually I can access my dataset, okay. So this is the code, just try to run. So try to connect. Let's select my account. I'll just give allow. Okay guys, it has mounted. Now if I refresh here, so you will see this drive option. Now just go into drive, and just select that folder you have kept your this one your data. So I think I kept inside my courses. Here I have YOLOv8 segmentation, this folder, okay. So here what I'll do, I'll just copy the folder path, and here I mentioned this thing, okay. Just paste it simply here. So for me, I already did. And now the change the directory, okay. First of all, you are in content, so let me show you. if you just execute this command pwd, so you are in your content directory right now. Okay, but I just need to go inside that directory. Okay, so just write cd means change directory, and just give the folder this path. Okay, path of your root folder. Now if I execute this one, now it will change. Now if I again execute this pwd, that means present working directory, now it has been changed from content to this YOLOv8 seg, which is nothing but this folder. Okay, now if you want to see like whether it's showing all the files or not inside that folder, just try to execute that command called ls. Okay, ls means list everything. Okay, see here. Okay, all the things are there. Now guys, we have successfully done everything. Now it's time to execute our training command. So it's like pretty much good. What I feel like this YOLOv8 here, you just need to like upload your data, and you just need to run some of the command, and every job would be done automatically. Okay, so here you just don't need to configure anything. Only you need to configure one thing. Let me show you. Before that, first of all, let me discuss about this command. So you're running YOLO. Giving task is equal to segment, because here you are performing segmentation. Mode is equal to training, because here we are training our model. Okay, and model, I'm providing the same model. Okay, data, here I'm giving data is equal to data.yaml. Okay, why this data.yaml? Here if you see in this directory only data.yaml, this file. Okay, so this file will contain the path of our images. Okay, now how we can set the path, let me show you. First of all, let's discuss. So here actually I'm giving epochs is equal to 10, so let's give 10 epochs, but for you can increase the epoch size. But here actually you won't be getting good accuracy, because our data is like very less, just 7 data for training. Okay, 7 images for training, and like 3 images for validation, I think. Okay, but if you are taking more images, okay, so you will get pretty much good results. Okay, so I'll show you that one. And image size, I've just mentioned 640. Okay, you just mention the image size based on your image resolution. Okay, and make sure you have given this thing argument called save is equal to 2, otherwise you won't be getting this runs folder. Okay, so everything is done. Now what I need to do, I need to change this data.yaml configuration. So for this I will open my drive. Okay, basically I will open this data.yaml file. So I have kept inside my my course, and here I have kept YOLOv8, and this is the data.yaml. Okay, I will open this one, and here I just need to change these are the path. Okay, so what I will do, I just first of all need to change my training image file path. So where I kept my training image inside my cell data, inside train, and this is the image folder. Just copy the path and just paste it here. Okay, okay, this is the entire path of our image, training image. Okay, now training is done. Now I just need to do for the validation. So I'll open the validation image, copy the path and mention here. Okay, yeah, now let's do it for test image also. So I will open the test image, copy the image path and paste it here. Okay, so that's it guys. You just need to make these changes because everyone will have their like different path. So that's why it is important to change this path. Okay, don't use my path, otherwise it will throw error. Now make sure you have saved this file. Just press Ctrl S, okay, from your keyboard. It will save and close it. Okay, now we are ready to train. Before that, let's yeah, okay, everything is done. Now let's execute this cell. So first of all, it will get the model and it will load the architecture. See guys, this is your model architecture. Okay, and it will look for all the images in that folder. See guys, here if you see, it found 7 images for training. Okay, now see guys, it has started the training. Okay, the epochs is running. If you see all the MAP score and losses, everything. Okay, and the log is pretty much good. You can track everything here. And see guys, this training is like quite fast. Okay, although my image size is less, but again, if you take lots of images also, you will feel like this training is like very fast, okay, than your Detectron 2. Okay, see guys, all the epochs has been done. See guys, our training is done almost. Okay, so see guys, and this is your final result. You will get this is your MAP score and all. Okay, again I'm telling, just increase the image because I just kept 7 images for training, just to show you how you can train it. But for your case, if you are training your custom image, make sure you have lots of data there. Okay, Now it has saved everything inside this run folder. So again, let's open our run folder and see everything. So I'll refresh here and I'll find this run folder. Inside run, it has created segment. Inside that, it has created train. Okay, and here it has saved all this curve. Okay, like this accuracy curve and all results.csv, results.png, everything it has saved. Okay, so and it is also saved my model, training model, which is nothing but base.pt and last.pt. So I'll be using this base.pt. Now let me visualize some of the graph to show you. Before that, let's execute this cell. It will list down everything, okay, in that train folder. Now if you want to plot this confusion matrix, so just run it. Make sure you are giving the same file path inside runs segment train, runs segment train. You have confusion matrix.png. This file actually I'm rendering. Okay, so here if you see, this is my confusion matrix, and you can also plot your result.png. So inside result.png, actually you will see all the losses graph. Okay, then accuracy graph, everything you will see here. Okay, here if you see, so here what is happening, as per your epochs is increasing, your loss is decreasing. Okay, and as per your epochs is increasing, your accuracy is also increasing. Okay, if you see these logs, but initially it would be zigzag because initial 10 to 20 epochs, actually you will see some random results, but if you increase the epoch size, you will see like it is it would be like improving the accuracy. Okay, now if you want to like show some validation batches image, so these are the batches, and you will see some overlapping issue would be there because I kept only 7 images for training. That's why you are having this issue. But if you increase the image size, okay, if you increase your data, so you won't be having this issue. Now let's validate our model because we have trained. Now this is the command to validate. So just run YOLO task is equal to segment, mode is equal to validation. Previously we are providing train, now we'll be providing validation. Model, I'm providing my model, which is nothing but this base.pt inside weights. Okay, this base.pt, just copy the path and paste it here. Okay, base.pt, and data is equal to data.yaml. So it will pick this validation images. Okay, validation images from that folder, and it will apply the validation and it will give me the MAP score. See guys, okay, this is your final MAP score and all. Okay, we'll get here. So every loss MAP score you will got here. So, and if you refresh here, so inside runs folder, it will create another folder called valid. Yeah, val. Inside that, it will save all the graph. Okay, you can refer later on. Now it was for validation. Now let's do inference using our trained model. So this is the command. Just write YOLO task is equal to segment, model is equal mode is equal to predict, because here I want to do predict, and model. Initially I was using this YOLO model from their model zoo, but now I will be using my model, which is nothing but this one inside train weights. Okay, base.pt. This model actually I'm using here if you see. Okay, so I'm providing this model, and confidence score I'm keeping same, and source. Okay, what is my source image? I've kept my test images inside test folder. That's why I'm giving cell data, because inside cell data I have test. Okay, and inside that I have all the images. Okay, and I'm giving this argument save is equal to true. Now let's execute and see whether it is able to predict or not. Okay, everything it has saved in this directory. Now if you want to see, just refresh, and inside this one runs, you will get another folder called predict. Okay, if you open the predict, you will find all the images it has saved here. Okay, so in my test data in my test folder, I just only had two images. Okay, that's why it has saved 2 images after doing the prediction. Now if you want to visualize them, this is the command, try to run. So I'm just giving this predict file path, and I'm telling print all the JPG. Okay, render all the JPG image inside that, and this is my final prediction. Okay, see, it is detecting this cell. Okay, it is segmenting out this cell. Okay, see, cell. But although there are some overlapping because of like very less images. Okay, just try to increase your data. You won't be having this overlapping issue. Okay, so yes guys, that's how actually we can perform image segmentation, or you can talk about instance segmentation using YOLOv8. Okay, it's like very easy, just plug and play kinds of thing. Okay, just refer this notebook and change your data, that's it. Okay, you can use any data set. Make sure this data set would be in YOLO format, and I already showed you what is the YOLO format data, and you can use RoboFlow to get the data. Otherwise, if you want to annotate your own data, you can annotate. You just use some of the tool, okay, like label me or any other tool, I try to convert that annotation file to txt format. Otherwise you can also annotate your data using RoboFlow also, it is also possible. Okay, now if you have some other format, okay, suppose you have annotated your data to XML format. Now if you want to convert them to, like, you can say YOLO format, it is also possible. RoboFlow already provides one API. So just open this link. Here you will see it supports like many things. Suppose see, if you have your Coco JSON format, if you want to convert that thing YOLOv8 format, okay, that means to .txt format. So try to refer the documentation like how you can do it. Okay, like that you have so many like converter, just try to refer that, you can also do it. Okay, so yes guys, congratulations, I think you have learned like how to do image segmentation. Now it's time to explore from your side, try to pick up any data set, try to do image segmentation, okay, and try to make awesome projects. Okay, so yes guys, this is all about from this video, and from my side I think you have liked this video. If you want this kinds of video more, just try to subscribe to my channel and share this video with your friends and family. Try to give a one like, okay, and try to do comments in the comment section, okay, how was the experience and all. Okay, and if you are facing any issue, you can ping me in the comment section. Okay, I will try to reply. Okay, so yes guys, thank you so much for watching this video, and I will see you next time.